Hello everybody, in this video I'm going to be talking about proportions and similar figures. What I have right here are two similar triangles. This one is triangle ABC. This little symbol means similar to, and over here we have triangle QRS. So triangle ABC is similar to triangle QRS. Now a couple things are true about similar triangles. One of those things is that their angles or their corresponding angles are congruent. The order of the lettering when naming these triangles and saying they're similar is very important, because if the first letter is an A here and the first letter is a Q here, that means that angle A is congruent to, that's what this symbol means, angle Q. So angle A is congruent to angle Q. So we can check that by moving this on top of it. So angle A and angle Q, whoops, not too far, are the same. It also means that the second letters have congruent angles. So angle B should be congruent to angle R. And what we mean by congruent angles means they have the same measurement. So I'll match those up. B and R have the same measurement. And finally, oops, did I change the order? Doesn't really matter. I guess the big one was over here. The small one was over here. That's fine. It also means that angle C, the measure of angle C and the measure of angle S are the same. And again, I'll drag this on top. C and S are going to match up nicely, and they have the same angle. There's more stuff about congruent triangles that's nice. So we know the line segment AB, if I make a fraction and I say AB over FG, I'm sorry, AB over QR, let's make that. So AB over QR is going to be the same as AC over QS, which is going to be the same as BC over RS. So effectively what we're saying is the distance between A and B right here, which is 8. So now I'll do this with numbers. So the distance 8 over the distance QR, which is right here, 12, is going to be equal to AC, which is 12, over QS, which is 18. And that ratio is also going to be equal to BC, which is 10, over RS, which is 15. And so if you take a look at all these, they all reduce to 2/3, right? 2/3 equals 2/3 equals 2/3. And so by having similar triangles, you can set up not only, you know that not only are there equal angles, but the ratios of certain sides to certain sides are always going to be the same. Okay, so, and we call these corresponding sides. So notice A and B are next to each other here, and so they are going to correspond to QR, right? AB, QR. And then BC are next to each other here, B and C, so they will correspond to RS. So BC, RS. And then also A and C are the outside ones here, and so Q and S will go together. So AC corresponds to QS. And so when you get those corresponding sides, you can make proportions. There's also another set of proportions you can make. So if I put AB over BC, for instance, AB over BC, that's going to be the same as the corresponding ratio here. So AB QR, so that's going to be QR over, and then BC was this one, so RS. And we can check that out. So AB over BC was 8/10. and then QR over QS is, let's see, QR over RS is 12 over 15, and those both reduce to 4/5. Okay, so when you get similar triangles, you can make proportions, and that will help you figure out the lengths of some unknown sides. So one of the really cool things you can do with that is in engineering. So picture we have a real big building right here, and the height of this building is the same as the height of a right triangle. And let's say the shadow of the building is right here. So this is the shadow, and it'll go from the base of this building all the way to some point, okay, on the street somewhere. And then if we picture the sun, let me move everything down real quick here. If we picture the sun, stop moving. Picture the sun somewhere up here. Here's the sun, and its rays are coming down on the earth, and it will hit at this angle here. The sun and the building is what creates that shadow here. And so here's the shadow, here's the height of the building, and then this angle here is the ray of sun coming down. Now if you were to have a person, which we do right here, a purple person, and we managed to set him up perfectly, or her up perfectly, so that his or her shadow came just to this edge here, and her shadow was, from her body to this point here. She also creates a right triangle. So her height is this edge here. Here's the angle of the sun, or the ray of the sun coming down, and this is her shadow. So there, so she creates a right triangle, and the shadow of the building creates a right triangle, and those triangles are similar because the ray of the sun never changes the angle there. So this angle we know is the same. We know this angle is the same because it's a right triangle, and we know that this angle is the same. So we know that we have similar triangles. So what can we do with that? Well, if this big triangle, we can measure this distance real easily, the big shadow of the building here, and let's say it's 15 feet long. We can also measure very simply the distance of the shadow of the person, and let's say that's 3 feet long. Alright, so this is the shadow of the person. Put a little arrow there. It's also really easy to measure the height of the person, so we'll say this person is 5 feet tall. What's not easy to measure is the height of this building, so we don't know, so I'm just going to put an H right here. But remember from the previous picture that I had, is we can set up proportions to figure out this missing piece. So the proportion might be, and like I showed previously, there's a couple ways you can set this up, but let's do it like this. Let's do shadows over height. And so the shadows of the, and then we'll say person and building. So the shadow of the person was 3. The height of the person was 5. The shadow of the building is 15, and the height of the building is some unknown value. Now, if you remember from the previous video, when you have two fractions being equal, we can solve them using cross products. So I'm going to give us a little room right here. And so we know that 3h, 3 times h, is going to equal 15 times 5. And so 3h is going to be, whatever this is, 15 times 5, I believe, 75. And so h is going to be 25 feet. So we know, using similar triangles and without measuring at all, that the height of this building is 25 feet. So the plan for Monday is to measure some tall buildings around campus or maybe town or something using just our shadows. So that's it for the video. Thank you very much.